Ayan. So, welcome to this fourth lesson on Laplace transforms. So, in this lesson, we'll discuss examples of getting inverse Laplace transforms. So, we have three examples in which we will illustrate how to get yung mga inverse Laplace transforms ng mga common transforms. Okay? So, we will demonstrate paano natin gagamitin yung mga napag-aralan natin from the introduction, lesson number 1, the properties of Laplace transforms, and yung ating third lesson, yung Laplace transforms ng mga derivatives and integrals. Okay? So, let's start. So, for our first example, we are to find the function f of t given this Laplace transform. So, we have here a Laplace transform of 3s minus 137 all over s squared plus 2s plus 401. So, sa unang tingin, kahit kabisado natin yung mga formulas ng common Laplace transforms and yung pagkuha ng derivative and integral, hindi natin siya agad makikita kasi yung given sa atin is a transform na simplified na. So in this case, we will have to dissect itong transform natin para makita natin saang formula natin siya i-inverse. Okay? So, in this case, the first or yung usual na ginagawa ng karamihan is to do completing squares. Okay? So, kung mapapansin kasi natin yung baba, pwede natin yan i-complete yung square para magiging dalawa na lang yung ating term. So, in that regard, lalabas ngayon yung ating s squared and some constant na naka-squared. So, pwede na natin siyang i-relate dun sa mga formulas natin. So, yun yung ating approach in this problem. So, first, nag-introduce tayo ng plus 1 and minus 1 sa numerator and then yung plus 1 and minus 1 sa denominator. So, tawag natin dito, we are completing the square, no, ng ating denominator. So, by adding a 0 in the numerator and denominator, wala namang nangyayari dun sa ating fraction. So, pwede natin gawin yon. Actually, pwede tayo maglagay ng plus 100 minus 100. Sa baba naman, kahit ano na. Basta, i-add natin ng 0, hindi mababago yung value ng ating fraction. Okay? So, sa pag-complete ng squares, yan, i-simplify lang natin. So, anong nangyari dyan? We now have 3 times s plus 1 minus 3. So, dinistribute lang natin itong 3 sa mga term na yan at niwalay natin yung isang 3, yung negative 3. Bakit? Kasi sa baba, pag kinompleto rin natin yung square, meron tayong makikita s squared plus 2s plus 1, which will now become s plus 1 quantity squared. So, very strategic yung pag-complete ng square. So, ganun din sa numerator. So, hanggat maaari, same yung same terms para mas madali natin ma-solve yung inverse. So, sa numerator, we have this value na naiwan, minus 3 minus 137. So, mangyayari dyan, maging minus 140. Sa denominator naman, we are completing the square. So, we now have s squared plus 2s plus 1. And then, yung minus 1 natin yung sasama sa 401. So, mangyayari dyan, magiging 400. Okay, so, the answer for the completing the square is now 3 times s plus 1 minus 140 all over s plus 1 squared plus 400. So medyo nagkakaroon na tayo ng konting resemblance dun sa ating mga formulas kasi meron na tayong nakikitang square dyan, and yung 400 is a perfect square, and then yung ibabaw meron na tayong dalawang term, no, na pwede nating pag-iwalayin by the virtue ng linearity theorem. Okay? So yun na nga, dahil nakita natin na meron siya, pwede natin gamitin yung linearity theorem, paghihiwalay natin tong dalawang term na to. So, dun sa first term natin, yan, ito yan. Okay? So, 3 times s plus 1 all over yung ating denominator. Okay? Minus 70 times 20 all over s plus 1 squared plus 20 squared. Okay? So, kung mapapansin natin, itong unang term, malapit na siya dun sa ating sign. Right? So, meron tayong s dito, then meron din tayong s dyan, then meron tayong perfect square. So, itong 3, kahit wag na natin pansinin dahil lalabas lang naman yan as constant. No? Pwede nating i-factor out yan. So, hindi yan makaka-affect dun sa Laplace or inverse Laplace transform ng ating function. Okay? And then yung second term naman, so that's minus, nagamitan natin ng linearity theorem yan. Then ganun din dito, parang ito naman ay sine din or cosine. Okay? So 20, constant yun na sa ibabaw, and then sa baba, meron kang dalawang perfect square. Okay? So, i-rewrite lang natin ulit dito sa baba, no, na ito na yung ating simplified version ng ating given. Kung mapapansin natin, from this form na medyo walang resemblance sa ating mga transform formulas to this form na somehow meron na by completing the square. So that's the essence ng ating first example. We can manipulate our transform such na meron tayong makukuhang malapit dun sa ating formulas. So, we still have to find yung ating f of t. Wala pa tayong ginagawa dito, nire-write lang natin yung ating given. So yan. I-rewrite lang ulit natin yung ating given. And then, pansinin natin yung ating table ng formulas, no? Sa first term, mapapansin natin na somehow malapit yan sa cosine omega t. So, meron tayong s sa ibabaw, s plus 1, and then meron tayong s sa baba. So, dahil meron tayong nakikitang s plus 1, so masasabi natin na pwede natin gamitin yung principle ng shifting theorem, right? So, dahil meron na nag-shift na tayo ng s, so that's the first shifting theorem na magagamit natin dito sa term na ito. Same goes with the second term. So, dahil constant sa ibabaw and then meron kang perfect square sa baba, magagamit natin yung ating sine omega t na formula. Okay? So, to get yung ating f of t, we will now use the definition ng ating inverse Laplace transform, that is yung squiggly L raised to the negative 1 para ma-note natin na yan ay inverse transform ng ating given Laplace transform. Okay? So, yan, inire-write lang natin ulit. Okay? So, for the first term, gagamitin natin tong e to the at cosine omega t. So, ganyan yung kasi yung itsura niya. No? Then, for the second term, ito ring e to the at sine omega t. So, gumamit tayo ng linearity theorem. We demonstrated linearity theorem, and then we also demonstrated yung first shifting theorem dito sa example na to. Okay? So, para ma-rewrite natin ng maayos na ganyan, i-determine natin ano ba yung a natin dyan and ano yung omega. So, ayan. By inspection, we now have a equal to negative 1 dahil yan ay s plus 1 pero dun sa formula natin kasi s minus 1, di ba? So that will be S minus minus 1, right? And then, yung ating omega, kita-kita naman, that is 20. So, therefore, our f of t, by using the inverse ng Laplace na to, will now become e to the a, dahil a natin is negative 1, negative na yung ating exponent. And then, at, cosine ng omega t, that's 20t. So, yun na yung sagot natin dun sa first term. And then, sa second, that will be minus, dahil minus naman yung nakikita natin dito. 7, inilabas lang natin yung constant dyan. And then, e to the minus t, dahil yung ating a ay negative 1, sine ng omega t. So, omega is equal to 20t. Okay, so ganyan yung pagsagot natin sa ganito example na somehow hindi natin makita yung given dun sa table ng formulas natin. So, kailangan natin i-complete yung square. Isa yan sa mga tool na gagamitin natin para magkaroon ng resemblance yung ating example or yung problem. Okay? So, just to finalize yung ating sagot, we are factoring out yung e to the negative t dun sa parehas na term. So, yung final answer natin, f of t is equal to negative e to the negative t multiplied to 3 cosine 20t minus 7 sine 20t. Okay? So, that's it. For our next example, we are to find out the inverse Laplace of 1 all over s times s squared plus omega squared. So, sa unang tingin, kung mapapansin natin, parang kitang-kita na natin na gagamitin natin yung cosine. Right? Dahil dun sa first example, nandun na yung formula. Or yung sine, actually. Sine omega t yung pinakamalapit dyan dahil yung ibabaw natin is a constant at hindi naman s. Okay? So, more or less, meron na tayong idea paano natin isa-solve to. Kaya lang, may nakita kasi tayong s dito sa harapan. Right? So, medyo mapapaisip tayo paano natin isa-solve yan. Okay? So, recall na sa lesson number 3, no, dinefine natin yung pagkuha ng inverse ng f of s over s. So, ibig sabihin, hanapin lang natin yung f of s divided by s, makukuha natin yung inverse Laplace niyan. And in that sense, i-rewrite natin yung ating given to this form. No? That's 1 all over s squared plus omega squared over s. Okay, so, para magiging itsura siyang f of s over s, which alam na natin kung paano yung gagawin. Right? So, kung maalala natin, sa lesson number 3, ang formula ng inverse Laplace ng f of s over s is actually the integral from 0 to t ng f of tau d tau. So, gagayahin lang natin ito, susundan lang natin ito sa pag-solve nitong particular example na to. Okay? So, before that, isolve muna natin yung ating f of s. Okay? So, yung f of s natin, ito yung red font na yan, solve muna natin yan. So, para ma-solve natin yan, nag-introduce ako ng 1 sa numerator. So, that's omega over omega. So, pwede tayo mag-introduce ng 1 sa numerator natin dahil it will not change yung ating fraction. So, dahil nag-introduce ako ng omega over omega sa numerator natin, masasagot na natin yung ating inverse Laplace for this particular Laplace transform using this formula na sin omega t is equal to, the transform of sin omega t is equal to omega all over s squared plus omega squared. Kaya lang, syempre, may maiiwan na 1 over omega, kaya nagkaroon tayo ng denominator dito. Okay? So, yan yung gagamitin natin mamaya sa pag-solve ng ating inverse Laplace transform. Hindi pa yan ang sagot. Okay? So now, balik tayo dun sa given. We now know that we need to find the inverse Laplace for this expression. Okay? And given na alam natin yung formula na inverse Laplace ng f of s over s is equal to the improper integral from 0 to t, f of tau d tau, gagamitin na natin yan. So, it is now equal to the integral from 0 to t nung ating nakuwang inverse Laplace dito. So, that's sine omega tau all over omega d tau. So, ginamit natin dito yung principle ng Laplace transforms ng mga integrals. Okay? Para magkaroon tayo ng inverse. So, with that, evaluate lang natin yung integral na yan. We will have the negative cosine omega t all over omega squared. Yun yung ating sagot sa integral na yan, which it will need to be evaluated from 0 to t para maging f of t na yung ating sagot. So, it will now become equal to 1 over omega squared. Then, pagka t, that's negative cosine omega t. Ito yan. Plus or minus negative cosine omega 0. So, kaya magiging plus itong ating next term dahil minus na negative pa. So, cosine 0 will become equal to 1. Now, ito na yung ating final answer. The inverse Laplace ng 1 all over s times s squared plus omega squared is equal to 1 over omega squared times 1, nanggalingan dito sa cosine 0, right? Minus cosine omega t. So, in this example, we demonstrated yung paggamit ng Laplace transform ng mga integral. Okay? And then, ginamit natin yung Laplace transform ng sine. Then, yung knowledge natin sa algebra is very important dito sa pagkuha ng mga Laplace transforms. Okay? So, let's move on to our last example in solving inverse Laplace transforms. So, for this example, we are given, again, parang example number 1 and example number 2 na pinagsama dahil may nakikita na naman tayong S dyan. Maaari, we're not sure, but then let's try to solve yung example na yan. So, we are to find f of t. F of t for the Laplace transform given 1 over s times s squared plus 3s plus 2. Alright? So, dito, pwede natin gamitin yung ating factoring dun sa expression na s squared plus 3s plus 2. If-factoring natin yan para magkakaroon tayo ng tinatawag natin partial fraction. Okay? By using partial fractions, masasolve natin yung ating mga inverse Laplace transforms ng mas madali. Okay? Ito yung example na mag-illustrate kung paano kadaling mag-solve ng Laplace transforms by using partial fraction. Okay? So, hihimay-himayin natin yung ating partial fraction depende dun sa laman ng ating denominator. Okay? So, ang sabi, pag partial fraction, ito yung ating first expression, a. Yung a is a constant na kailangan natin isolve. Over s, dahil yun yung first factor ng ating partial fraction, plus b, constant ulit na kailangan natin isolve, over s plus 1, yan yung second term, plus c, na kailangan ulit natin isolve, over s plus 2. Okay? So, simple lang ang technique dito sa partial fraction. Lalo kung non-repeating yung ating factors, kasi may chance na repeating, yung mga ganong partial fraction, iba rin yung approach. Okay? So, in this case, non-repeating or distinct yung ating kailangan i-solve. So, meron tayo dito tinatawag na technique na takip-takip. Okay? So, to solve yung ating A, so yung ating original term, so tatakpan natin yung S. Okay? Tatakpan na natin yung S or aalisin natin yung S. and then evaluate, sa substitute natin yung value ng s na yun dito sa ating fraction. So that will be equal to 0 dahil wala naman siyang kasamang constant dyan. So evaluate natin yan to get the value of a. So yung value ng a will become 1 over, so substitute natin yung 0 papunta rito and then dito rin. Okay? So yung a natin will be 1/2. So yung 1/2 na yan, isa-substitute natin pabalik dun sa ating a para magkakaroon na siya ng number. So itatabi lang muna natin yan and then kumpletuhin muna natin yung b at saka c. Okay? So to solve yung ating b, takip ulit natin, tatakpan naman natin yung s plus 1. So ang matitira na lang is 1 over s times s plus 2. So ang value naman na isa-substitute natin is s is equal to negative 1. Nagagaling yan dito. No? Ini-equate natin sa 0 and then isa-solve natin yung s. Therefore, s is equal to negative 1 na isa-substitute natin dyan para makuha natin yung b. And b now becomes negative 1. So that will be 1 over negative 1 times negative 1 plus 2. So negative 1 yung b natin. So ulit natin dun sa ating partial fraction. Then kumpletuhin na natin yung c. Ganun ulit. Takip-takip ulit. Tatakpan ulit natin yung s plus 2. Ang matitira na lang is 1 over s times s plus 1. So, ang gagamitin naman natin dito na c or na s is equal to negative 2. Okay? So, substitute natin yung s is equal to negative 2. We'll now have c equal to 1/2. So, yung c natin na 1/2, babalik natin ulit dun sa equation. We now have a representation ng ating f of s na nakahiwa-hiwalay. Okay? So, pwede na natin kunin yung inverse Laplace niyan, which is napakadali dahil kung mapapansin natin, dun sa first term, s lang yan, so constant. Sa second and third term, may plus 1 lang yan, so that will be exponential, right? So our f of t, dun sa first term, that will be 1/2. Gamitin natin yung formula ng mga transforms. Then sa second term, so that will be, dahil negative 1, so negative na yan, e to the negative 1t. So dahil negative 1 siya dahil s minus negative 1 to. For the last term, we have 1/2 times e to the negative 2t. So, negative 2 siya dahil yung denominator natin is s minus negative 2. So, that completes our f of t. Okay? So, napaka-helpful ng ating partial fraction sa marami sa inverse Laplace transforms. So, pakitandaan na lang kung paano tayo kumuha ng Laplace ng partial fraction. Okay? For the last term, we have 1/2 times e to the negative 2t. So, negative 2 siya dahil yung denominator natin is s minus negative 2. So, that completes our f of t. Okay, so, yan ang example natin or mga example natin in this lesson. Marami pa tayong isa-solve ng mga Laplace transforms and inverse Laplace transforms. So, I hope meron kayong nag-gain ng mga technique sa pag-solve ng mga inverse Laplace transforms. Sa unang example, we demonstrated yung theorems natin. And then, gumamit tayo ng table, meron tayong formula. Sa second example, gumamit tayo ng shifting theorem, right? And then, sa third naman, gumamit tayo ng partial fraction to solve or to simplify yung ating expression na given. Okay? So, with this, I will end this lesson. Okay? Maraming salamat and see you on lesson number 5. We are going to solve differential equations using Laplace transforms. Okay?